Hello. In this video, we're going to go through part 2 of Learning Target 231, which is to be able to graph and interpret information related to a real-world quadratic. So in this, you are welcome to graph by hand. So often on tests and things like that, I'll have a blank coordinate graph for you to use. However, I also want to show you how to use your graphing calculator for this because you will have your graphing calculator and you can use that to help you with your context problems. So this one is saying that the Hulk is standing on a cliff and throws a rock into the air. Whenever we're like launching something, it will follow a quadratic path because you'll like launch it up and then gravity will do its thing and then we'll fall back down. So the equation to model the height in feet of the rock per second can be shown by this equation. Create a graph, then answer the following questions using proper units. Be sure to label. So I don't actually need you to do the graph unless you want to. Otherwise, you can just do it in your calculator and then use your calculator graph to answer these questions. The first thing I'm going to do is underline my units because I'm going to have to use these units when I answer the question. So I need to make sure I know if it's feet or miles or meters or whatever. So the first thing it asks is, what is the starting height? And I can find that from the equation before I even graph anything because our starting height is always our C value. So whenever it asks for where something starts, it's always your C value. So in this case, our starting height was 120 feet. But then our maximum height and how long it takes for the rock to return to the ground, I'm just going to draw a quick sketch. This obviously is not going to be to scale, but if this is the rock, let's say it goes up like this, hits back down. Maximum height is asking for this, the top part. And then when it returns to the ground, it's asking for this part, which is an x-intercept. So we need to find those two pieces using our calculator. So if you are at home and you don't have a graphing calculator, you're going to want to wait to watch this video until you do have one, so in class at some point, because this is going to be specific to this one. If you're at home and you want to do the rest of this problem, you can also use desmos.com, DESMOS.com, and you can use their graphing calculator to do the same thing. So for us though, you're going to start by going to y equals, and you're going to graph your equation in your y equals. You have to use x instead of t though, so just be aware when you graph it, you'll have negative. The x button is below the mode. So I have my equation now, and make sure you pause this video if you're behind me at all so you can do it with me. So then you're going to go to graph it, and sometimes it will look perfect and you'll see the whole parabola and everything will be great. And sometimes it won't. So you'll just see this and that does not look like a parabola. So you'll need to mess with the zoom or the window to be able to adjust it. I think it's easier to adjust using the zoom button. We'll talk about window later. So the first thing I always do is I go to zoom, and if you scroll down to number 0, or if you hit number 0, it's called zoom fit. And zoom fit is the first one I always try. So I'm just going to hit enter on zoom fit. And what it's trying to do is it's trying to fit the parabola into the screen, into this little window. Now it did something, it didn't do a great job. I still can't see my maximum point or my x-intercept over here, so it's not doing great. So I need to zoom out. So I'm going to go to zoom again, and I'm going to zoom out. When you zoom in or out, you have to hit enter twice. So I'm going to hit enter once, and then I'm going to hit enter again. And now I can see most of it. I can for sure see where my maximum is. I can't quite see where it touches this x-axis, but let's do the maximum first. So once you can see the pieces that you need to see, we're going to use this calculate button, this calc button. So we're going to hit second and trace. And you can calculate different things in your graph. The ones that we're going to focus most on are 2 through 4, so zeros, minimums, and maximums. Right now I'm looking for my maximum, so I'm going to hit number 4. And then it's going to ask you 3 questions. It's going to ask you for a point to the left, a point to the right, and where you think the maximum is. So I'm kind of like walking along my little graph, and I want to hit enter when I'm to the left of the maximum. So here's my max. To the left of that, there's my point, hit enter. Then I'm going to go to the right, and basically what I'm doing is I'm choosing 2 points where my maximum is between. So I'm going to go to the right and hit enter. And now you can see basically what this is saying is the maximum is somewhere in between these 2 arrows, and we need to figure out where it is. So then you're going to go and you're going to guess. Your last thing you're going to do is guess where you think it is. This is where I think it is. And then it will tell you what your maximum value is. So my maximum value up here is 20, 520. If it has a long decimal like this, you can round it. It's just trying to get very close. And so when it's asking me my maximum height, I need to know whether that's my X value or my Y value. Height is always your Y value because that's a vertical distance. Your maximum X value is going to be like time usually. So what this 20 represents is the number of seconds it took to get to the maximum height, but our maximum height is 520. And it took 20 seconds to get there. Now, the last one is how long did it take for the rock to return to the ground? And I can't quite see that spot, so I'm going to zoom out one more time. So zoom out. Remember, hit enter again. And now for the point it hits the ground is like over here. So I'm going to try to estimate where that point is by calculating. So second trace. This time we're calculating a 0 because that is another word for x-intercept. So I'm going to calculate a 0. And again, it's going to ask me to go to the left, which for me that means above. Then go to the right. And then guess where you think it's touching. And so this tells me that my 0 is at 42.8. So essentially what it's saying is it took 42.8 seconds for the rock to return to the ground. So you can rewatch this video to kind of go through this process, but that'll be the same process you do each time. You graph it, you hit second and trace to calculate your maximum or minimum, and then you can calculate your zeros as well. Thanks, everyone.